Hi guys, welcome to coding world. So in previous video we have already discussed about what is sliding window technique, okay, and how it is useful for solving the coding problems of array data structure. Okay, we now in upcoming video we will also discuss about prefix sum technique, and also we'll see some problems based on sliding window technique and along with the concept of hashing and graph data structure. Okay, so we'll discuss this stuffs in a little while later. Okay, but now what is what I'm trying to say is, now I'm going to dry run for another example to to illustrate this sliding window technique. Okay, let's say we are constructing an array of 4 elements in which I have the element that is 10, 20, and let's say 30, and let's say 50. Okay, and let's say we are given a k value 3 and n as 4. Definitely n is 4, so these 3 parameters will pass as an argument of SW, this is sliding window technique function, and this function will at here it is returning max sum. So my max sum will return the the sum of the 3 consecutive elements, which is the maximum. Basically I have to return the maximum maximum sum of 3 consecutive elements. That 3 consecutive elements could be anything from where, but so it should be consecutive. It could be 10, 20, 30, it could be 20, 30, 50. That this is the possibilities. You cannot rotate the array, that means 50, 10, 20, yeah, you can say 30, 50, 10. That cannot be possible. You have to linearly find out the maximum of k consecutive elements. Okay, now suppose so in this problem definitely we are going to apply sliding window technique. For this type of problems definitely we are going to apply this sliding window technique. One thing, in various problems, suppose where we are to find the subarray maximum sum, circular subarray maximum sum, in that particular problem we can use 2 techniques. The first is sliding window technique. This is the first algorithm. Now we have already learned about it. In upcoming videos we will also learn about what is sliding window technique along with hashing. We'll also learn about 2 pointer method approach. We'll also learn about you can say how to calculate, you can say sliding window technique, and prefix sum technique, that I forget it. Prefix sum technique, sliding window technique plus hashing data structure. We'll discuss about them in detail. Okay, now let us focus here. Okay, so that is 10, 20, 30, and 50. Suppose k equal to 3. Suppose if I construct a window starting, definitely I will I will by default I will start my window from 0th index. Suppose if I construct this window of size 3, basically because 3 is already given as k value, so it will be 30 plus 20, that is 50, 60. Now there is called as current sum. So in my current sum what I have 60. Suppose I'm dry running, I'm showing how to dry run this code. Int current sum, that is equal to 0. That means initially I have assumed that my current sum is 0, and now in this loop, that loops runs for only k times. That means k value is 3, so this loop will run only for 3 times, and rest of the times this loop will run, and it will give you the max sum. Okay, now this loop is going to do nothing, but it will calculate the sum for the current window. That means for 0th index till index 2. This is 0 index, this is first index, second index, and this is third index. So it is now current sum will be from 0. Initially it is 0, now it will be updated to 60. And also I am assigning max sum, the value of current sum is assigning into the max sum. So now my max sum contains 60. But do you think that 60 is the correct answer? No, 60 is not. It should be this. If we consider this window, that is from first index to last index, that means third index, and if you calculate the sum, that is 5, 30, 80, 80, 20, so 100. So do you think 60? No, 60 is not correct. 100 should be the output. Okay, now let's check it if I'm getting 100 as or not. So now definitely next time when suppose now when I will construct the window for next time, definitely that window I have to shift by 1 position. Okay, from that means from first index I will construct, and definitely in spite of index 2 my window should point at third index. So what I could do is I have already calculated 10, 20 and 30 sum, that is 60. What I will do, I will subtract 10. That means the window, the you can say that this is the first leg, means the first leg of the window. Previously the place where the first leg of window is pointing, I will subtract the value of that element. That means I get 50. And what I will do, definitely my last leg window, that means the last leg of my window previously was at second index, now it is pointing at third index. What I will do, I will just simply attach the value at the last leg, that is third index, that is 50, and that is 100. So this is the approach, this is the this is very efficient approach. Okay, this could handle positive, negative, any type of elements, any number of elements. Okay, let's move ahead. Now let's erase this. Now you can say that max sum contains 60. Now it will start from int I equals to, okay, this loop. Basically this loop has already run for 3 times, and now rest of the time this will loop run. This loop will run for n times. That's why its complexity is big of n. Now my n value is 4. Okay, so definitely already this loop has run for 3 times, so definitely this loop now should run only 1 time, so to satisfy this big O of n time complexity. Okay, so definitely, and in one this loop will run for this only 1 time and it will give the output. Let's check it. It will start from int I equals to k, means it will start from this index, third index. And what I will do, I will calculate the I will array of I, means I value is 3. See, I am writing here I is 3, and what is the value of I minus k? You can see I minus k. Basically this is the last leg value and this is the first leg value. Last leg of this now current window, because my window has been shifted. Okay, now but previously when my window was my first leg of window was at 0th index, and that I have to subtract it, and now my current window's last leg points to the third index, that I have to include in my max sum. Yeah, you can say current sum I have to include. So I minus 3, I value is 3, k value is 3, so it is 0. Are you getting my point? Now array of I is 3, so array of I, what is the value of array of I? 50, so 50 minus array of I minus k, what is the value of I? 0, 0 means 10, isn't it? And that is 40, isn't it? 40. Now what I'm trying to say is this 40 is going to assign in the current sum. Previously current sum contains 60, now it is again adding 40. Now current, are you getting my point? Now it is contain plus 40, so it will be updated to 100. Now what I have to do, I have to also update my max sum. So what I will do, I will just simply take the maximum of the previously maximum sum and the now current sum. So this max sum contains 60, previously it contains 60, and now current sum contains 100. So I'll take the maximum of these two. Basically this max function is inbuilt, okay, is already available in C++. This is inbuilt function. This will give you the maximum of the 2 parameters that will be passed as an argument. Now my max sum contains 100, and definitely now suppose now k value is 3 and I value is 3. Basically k is assigning into I. Now suppose if I increment I plus plus, isn't it? Now I becomes 4 and n is also 4, so 4 is less than 4. No, 4 is equal to 4. So the condition becomes false. We exited from the loop, and after that we return this max sum. That means we'll return this 100. So in this way we can say that sliding window technique works perfectly fine. Now you can also say that suppose I'm considering 5 element. Okay, let me dry run this for. Okay, now try to understand what I'm trying to say. Okay, now my suppose k value is 3. Are you getting my point? Suppose k value is 3 and my n value becomes 5. Now we'll see how this is going to work for any input. Okay, for any number of n this is going to work. Okay, now let us say that k is equal to 3. Okay, let us construct the first window, because this for loop will give me the current sum for the first loop. Okay, now CS, current sum contains 30, 20, that is 50, and 50 plus 10, that is that is 60. And let's say this is not 60, let's say this is 0. Now everything will be crystal clear. Okay, now this is 0. Now current sum contains 60. Okay, now again I am maintaining a max variable and I'm assigning the current sum as max sum. Okay, now I'll enter into this loop for int I equals to k. Now what is the value of k? 3. So I value 3. Okay, and I minus, so I value 3. What is the value of I minus k? I minus k, definitely it is 3 minus 3, which is 0. Now what I will do, basically this, what is happening in, what is this two, this, what is doing, what is done by this thing is done, is doing nothing, but it is shifting the window. If you clearly see it, it is just moving the window, and I have to do, and this is the thing which I have to do also, I have to shift my window. Okay, now let's say, so what it will do, array of 3, that is 50, so 50 minus 10, that is 40, and it will assign it to, that means current sum contains 100, and I'll update my max sum as 100. Okay, now this is the maximum sum that I should be getting. Now I value from 3, now I becomes 4, and n value is 5, so this condition is again satisfied. Okay, now what is the value I minus k? I minus k 1. See, now this window again has been shifted via this condition. Now window is this. Okay, now let's see also what is the element, what is the value of at index 4, that is 0. Okay, and what is the value at I minus k, that is that is 10. So 0 minus 10 is minus 10, and we'll assign minus 10 into this. Now my current sum contains 90, but see, max sum will always be taking the maximum of the previously calculated max sum and the current sum, and now current sum contains 90 and previously max sum contains 100, so it will be overwrite, and it will be 100 as it is. And now my I value becomes 5, and n is also 5, so 5 is not less than 5, 5 is equal to 5. So we have exited from this loop and we have returning max sum, so output is 100. So you can now I hope that you are getting this concept very easily. I strongly request you to dry run for this, other inputs also, for negative elements also, and see whether you are getting the correct output or not. Okay, so, and definitely this is big O of n, and definitely space complexity is big O of 1, because we are not maintaining any visited array, boolean array, anything else. We are not maintaining, we are just passing this array which is entered by this user in this function to calculate the max sum. Okay.